Hello everyone, welcome to today's movie. In today's movie we'll take a simple time series dataset and we want to fit a model to that dataset, and we're going to use simple exponential smoothing, and we're going to use SPSS to actually fit the model. Once we got the model fitted, then we wish to provide forecasts using that model for the time points provided given. In a previous movie, we used Microsoft Excel, and this is example 11.6 in the textbook. So this is the Excel data series. So we got a year, 1960 to 2018. We're given a series value for each year, as you can see there. And the series value is the UK birth rate per 1,000 people. So in 1960, the UK birth rate was 17.5 per 1,000 people. In 1961, it was 17.9 per 1,000 people, and so on. What we want to do is we want to fit a simple exponential smoothing model to the data and then use that to provide a forecast such that in 2019, the forecast was 11.04. Okay, so there's the equation for the exponential smoothing, and there's the forecast equation, and this is the graph. The blue line represents the original data and the red line represents the simple exponential smoothing forecast. Okay, now remember these equations, this equation here, which is these equations here, depends upon alpha. So now what you could do is, what we want to do is, because if we change alpha, we have different solutions. We want to look at the solutions and we want to be able to minimize the error term. And the error term that we use is the mean square error. And you can also use the root mean square error. And the relationship between that and that is that this is the square root of that. Yeah? Okay, so look at the book, look at the previous movie as well. Okay, now if you were to minimize that based upon changing that, as we can see here, using the Excel solver, then we find that for 2019, the optimal value based upon the Excel model is 11.00. Note that the starting point for this smoothing constant there, S1 dash, is that's equal to the series value at that time point, Y1. Okay, let's look at SPSS, shall we? So there's the data set in SPSS. What we have to do first is we have to define the date and time first, because we've got some time series data. So click on data, then click on define date and time. Now we're dealing with years only, so just click on years and we start at 1960. Okay, and then click OK. So there's my date and time. The output file will tell you exactly what you've done, so I'm only interested in the data file at this moment in time. Then once I've done that, I can then look at fitting the model. So analyze, forecasting, and then what we want is we want to create a traditional model. And then once we've done that, we then take series and transfer that to the dependent variable box. And then once we've done that, we can then click on the method and we want exponential smoothing. Then click on criteria and we want simple. So click on continue. And then once you've done that, you can then look at the statistics and decide what statistics we want. So I think we'll have root mean square. We'll display the forecasts as well. Let's go to plots. Okay, so what we want to do is we have the observed values, the forecasts, the fit values. Now notice that SPSS automatically will provide you confidence intervals for the forecasts and fit values. So if you want to, click on those two as well. Let's click on save, and this will then give you your numbers in these columns. Okay, so it'll create 3 extra columns, one for the predicted values there, one for the low confidence limit, one for the upper confidence limit. Click on the options. Now we want, remember, to be able to predict for the first case after the end of the estimation period. Okay, so if you look here, look, I put the number in there, time point 60, and then all we need to do now is click OK, and it will tell us the model fit in the output file, as you can see there, but it'll also give you the predicted values there. So we can see, if I just change the number of decimal places for the predicted, let's put 4 in. So we can see there, look, that at time point 60, the predicted model fit would be 11.0000. If I go to Excel, scroll down, oh, it's the other one, isn't it? It's that one, there we are. It's 11.00, oops, 00. Can you see you get exactly the same answer? Okay. Now, at this stage, you can then, if you wanted to, you could then plot the graphs as well. So if you click on the graphs, legacy, line, multiple values of individual cases, define. Okay, then all we need to do is tell it what the lines represent. Well, the lines represent the predicted values there. Oh, we'll put series in. We put the predicted values in. And then if you want, you can put the lower and upper class limits in. But I won't do that now. You can look at that when you work your way through the book, etc. Okay. And then once you've got that, then all you need to do is click on OK. And there's your graph. Okay, there we are. There we are. So there's your graph. And if you compare with the Excel, there's the Excel version as well. So you can see that basically you've got the same graph. Okay. So it's complicated using Excel, much more difficult, but it's really easy using SPSS. Okay, but SPSS, remember, will use a slightly different starting point for your data set. Okay, so if I go back here and I scroll up, you can see there's 17.5, 17.5, 17.9. And if we come to Excel, can you see the solver version should give you exactly the same value, 17 point. So we don't normally write the first one in. So you can see you get the same numbers. Okay. Okay, so that's it for today. Bye for now.